Hello, welcome back. This is a third lesson of GS 170 Introduction to Computers. This is for the week 3 and about the software part of computer components. As for the reference, please read chapter 4 of the textbook. Here, just a short review of a previous session goes here. The computer is information systems, I said. Then this system is composed of hardware, software, and the user, and data, and procedure. Even if hardware, software, data are three more important the components. And in third industrial revolution that started around the 1970s, 80s, that this computer is an inevitable and essential components of our lives. And we said that why computers are so popular, why it is dominating our life. That's because it has the power of a saver. So speed, accuracy, volume, that's attributed to hardware. Then that work computer doing is very efficient, and it does repetition over and over again without being tired or without complaining. So in a sense that out of those 5 components or 5 factors of advantages, that first 3 is due to hardware, then the other 2 are due to software. So anyway, that all the relevant material, including syllabus and the textbook, is found at this location with that's actually Google Drive, or by reading this QR code through your app. Then the QR code reader app, then you will get the access to that directory. So today's agenda is that the software component. First day we talked about overviews. Second day we did hardware. Then third session is that about something about the software. Then fourth, fifth is more of a specific software like operating system and some of the programming languages. So what is that software? We'll have some definition about it. There are very long definitions it can be, or it can be very short. I'll make it short. And then how can we classify it? Because there are literally millions of software packages. So we can categorize them. And there are 2 groups. That's the system software and application software. And even if our textbook doesn't mention much, but because I have been a software engineer, that I would like to make some comments or very the short the coverage about the thing known as software engineering. That is the guide or methodology of creating software. Okay. Okay, I'm talking about computer software. What is it? First of all, we talked about that it is one very important component of computer system. And the software, what is it? It's a combination of a program and necessary documentation, such as user manual and other installation and maintenance instructions, how to use it. They must give that guidelines. Then there is the issues like when there is a problem, how would you find the solution? So all those instructions for using that software is also part of the software. So that is given in this form of a package usually. So you buy this package. And there are so many different kind of software. So most important part, of course, is a program. This is a CD. These days, not much of CD. Most of software you are downloading from the web. still that many software packages are sold with this CD on it or DVD on it. And in the DVD, there are also software or running program in there. So what is a program? That is instruction to operate hardware for process information. So series of commands, do this, do that, that kind of instruction is in the program. So we'll see how they look like at the end of this class. Then, so computer software, there are many of them. Really, I told you that the one makes a computer different from the other, or more useful than any other equipment, is that it can handle so much wider spectrum of a problem to solve. So there are millions of softwares. Actually, learning computer is more of learning how to use the software rather than hardware, even if that learning how to use the hardware is important, but it is relatively small compared to trying to learn hardware, the software part. So there are two big categories. One is the system software and application software. System software is a type of software that makes accessing hardware easy. What it is that hardware is electromechanical devices. There are a lot of electronics, very tricky, very highly electrical engineering related sets of instruction that change the voltage, make some motor change certain values. So that is not good for lay people. So we need a way of somehow that the certain kind of instruction somehow magically they run our software and get all the calculation graphics done, our letter or our documentation done. So that kind of there's some form of software that is used for accessing using this hardware, but bottom here, this hardware part easy for the user and possible or convenient. So that is a system software. So in a sense that the system software is talking to hardware. Then system software is somehow that interacting or talking to application software that's used for specific need. So for end user, it is closer to, pairs with user. Users will deal with applications. So for example, if we are doing web surfing, like using the Google Chrome or the Firefox like that, then that is application software. But that software also has a lot of connection with a certain group of software that is known as operating system, and there's also device drivers. Those things are directly interacting and making some instruction into the hardware. So they are more like in the book, it talks about the BIOS programs and the core software that is really dealing with hardware specific instruction. But very important to know is that user has no way of directing this hardware to do our intention, like drawing pictures or writing a letter or calculating my balancing my ledger, anything like that. So all we have to do is that talking to a software that is the very specific need to us, and then that in a way talks to another group of the software and eventually interacts with the hardware. So again, we typically have a word like a high level and low level. High means closer to human. Then low means closer to the machine. This is very precious to human beings, and this is just a tool that we are using. So that level, which one is closer to? That's the kind of difference. So hopefully that you know the difference between application and system software. Then, so in a way that there's some many diagrams goes this way. Hardware goes in here. It's about the CPU, the ISC, those things. Those things are covered by or interacts closely with the system software, including operating system and some utility program and some language process I'm going to talk about. Then that one also interacting with the application software. Then human beings will deal with the application software. So what you are going to use most of the time is application software, but when you log in or you start the logging into the computer, then some portion of this the system software known as operating system is something you will be accessing too. So the top level of this application software is user interface. So when you open up the computer, then in the part of the operating system, but there's a user interface part. That portion is more of application software, even if it belongs to certain operating system. So there, there's a thing known as GUI, graphics user interface, makes easy for the user to access hardware. Then productivity software is the name given such a way that this will actually let you do some work done and some products or some results done. Then the system software is operating system and other utility like the disk drives or virus checker or the maintenance program, like when there is a junk file, then clean it up, or there is the background music to play, that kind of a utility software. That's a portion of system software. Usually they are not something that giving you some results, but it's more like make your access to the hardware easier and convenient. Then actually there's another group. Usually this is written in a programming language called the machine code. They're directly interacting to the system. So this device driver is quite different for like a Mac machine or Windows machine or your Android machine, or if you they installed the new monitor, and that monitor, depending on the type of monitor, it may be different. So there are a whole spectrum of software, but for you at this moment is knowing that there are two groups. One is the system software. They are more of the setting the environment or make your access to the computer easy, and application software is where all the work is done. I usually give this kind of analogy. If you go to a building, then each building, a room has a lot of those settings, like the lighting and air conditioning, and sometimes needed a water line for if it is a kitchen or some kind of the lab, and there's some other tables or some floor spaces like that. Then those things are more of application system software. That's setting your work, setting your work environment, and it interacts with the light, the fixture, and plumbings, and any other heating control. Then if you are setting that on for classroom, then you will put some kind of devices, the equipments for the desks and podium and the blackboard, so that doing class is easier. Exactly the same space can be used for, say, kitchen, then you will need a whole bunch of other equipments. So given certain equipment, then you can make your the job or make your products like those cooking or learning be done inside that room. So the kind of a tool that making like a cooking or teaching classes or learning the classes is more like application software, and those environment like plumbing, light fixture, temperature control, those things are very much like a system software, and then the building itself is hardware. Well, they may, I don't know whether that the analogy be any help, but it's similar to that. Then the system software comes into several categories, but one of them is the operating system. So most important actually. So we'll talk about the Windows operating system that because it's most popular, but it's responsible for the management and accessibility of a computer system. So in the OS operating, so there's a whole bunch of this memory manager, processor manager, like that. So the operating system, system. First of all, system is there many components working together that we talked about. Then operating is not surgery, but it is more like something runs, something works. So in doing so, under the computing environment, there may be many things you're going to do. Like for example, you may be within usually your desktop, the computing or your laptop computing is not multi-user environment. But even if in that case you may be in a given time, your computer may be running many programs at the same time. So that is known as process management. So you say, oh, I'm just running one. That is, I'm using Microsoft Word only. Maybe, but meanwhile, there is always a virus checker that's running in the background. Or sometimes you send some document to the printer, and while it is being printed, you can do the work. So these days, all the computer system can do many jobs at the same time. That is known as multitasking. So multitasking can be done by somebody doing those traffic control. That's process management. That's part of a software or program, when you're actually instruction that just handling processes. So say computer science majors will learn separate course just for operating system. Then there gotta be memory. This is hardware part, of course. So processor was a CPU, or sometimes a disk, graphics processor, or network, the processing the units. So those kind of processors that gotta be managed or controlled by some supervisor. That is what operating system is doing. Then memory, you may have we talked about the RAM. So for example, my computer has the 4 gigabytes of RAM. And then RAM, random access memory, that's our memory where all the program can come in and go, and many different programs are residing at a given time. So to do that, we need a proper management, such a way that more than one program can be stored there, and when the program is over, then you take it out and put new the program inside those memories. So then management is important function. Then file, so it's all the data and all the necessary the information is stored in a place known as a file. So that file must be managed, so that I want to open my like a student file, and from there I can check out the grades of somebody. Then that kind of the data to access, I need the managing operating on. file. So that's the file manager. Then there also disk management. This one is a secondary storage. Remember, the memory is a primary storage devices, and then disk is a secondary storage. So the secondary one contains permanent storage. It's a slow and somehow less convenient than primary primary memory of to access. Nevertheless, it's cheap and it's permanent, and you can store a large amount of data. So hard drive. So for example, when you turn on your computer, then it takes some time. That process is known as a booting. Booting means that it's coming from the word bootstrapping. You have your shoes as the strap, so bootstrap. So you pull it out, and it's much longer than what you think it is. So that idea that the program triggers with one part of a program, that program that triggers another part, another one, brings in all the files and the necessary icons. So for example, in the window, that when you turn on, it takes some time to get all those icons and the screen set up before you start using it. So that kind of the information resides in permanent storage, because should be stored somewhere, but main memory, once turned up your computer, it's gone. But the file storage is, the disk storage is permanent. Secondary storage is permanent, so it comes from there. And if there's any update, you change your icon, you add or take away some of those icons, then it will be also remembered and saved as so. So next time you turn on your computer, then it will show just those icons that you saved, and those deleted is gone. Then another manager's work include that security. So virus must be checked, and if there's any attack in the middle of your computer usage, then it gives you warning and it stops it. So whether you know it or not, it does it for you. So on the background, that this operating system is very busy to make your usage easier and convenient. And then the user interface part again is somehow high-level operation part, but this one directly dealing with the user. So how to manage those the icons and how your mouse work, and sometimes there's a speaker or microphone works to handle your work. That kind of the operation being controlled by user interface part, so accessibility component. Old days, that all those accessibility of interacting or talking to computer was done by command. You got to type up those commands. Then that's too much. You got to memorize every command. That's very difficult or very prone to the forgetting. So a little later, there come menu-driven systems. So everything comes into the menu. So instead of memorizing everything on top of your head, that you see the list and you can recall, yeah, this is the item I have in mind. So which file you want to open, then you can see the number, then will that will remind you of which was the file you intended to open. And then, but soon that came more of the work. So there's the thing known as WIMP, or graphical user interface. Actually, it was called WIMP. Windows. So Windows is a metaphor of that, just like the world you see through your window. And so when you look at the window, then there are so many sceneries and so many items. So that's a window. Then icons, whole bunch of icons there. And then M is the menu. So it has also menu. It's coming from previous generations of interface. So when you click it, something, you know that in the Windows, that when you click in the mouse, the right button, then there comes with those menu items. Then last, the P is a pointing device, like the mouse or the digitizer or trackball, things like those. So it is used to be called a WIMP. Then people didn't like WIMP because it sounds like you are coward. So they changed the name into GUI, so graphical user interface. So that's a way that dealing with the computer gets more intuitive and easier. Older days, you just had to remember everything, like to see the file, you got to have a dir, and to get the file, the copy, you have copy A, the space B, like that. So it is, unless you're using every day, then you forget those commands. Then menu was a little easier, but until the time that those GUI interface came, things were much harder. We can talk about this one when we're talking about the Windows operating system later. Then these days, there is getting into fourth generation. That is, so it is given a user interface as a first generation command, second generation menu, third generation GUI, and fourth generation is a multimedia. Multimedia means that you can talk your command. So these days, there are some of the system that you can, like Google searches, you can just talk to your smartphone, then it'll recognize your voice and give you back with another sound by the speaker. So voice recognition, and then the voice synthesize, that function is given, and that a whole bunch of other methods of multimedia to interact with the machine. So this has been changed. Maybe you are confused that, or actually I'm making you confused that user interface is more like the application software. So, but it is a yes and no. It's these days coming within the system software or operating system. But there were times, or even these days, there are separate application software that just they're intended for helping you to access the computer system easy. So that exact classification sometimes getting a little fuzzy or overlaps. But anyway, purpose of operating system is making access to the hardware or using the hardware more convenient and very efficient. Actually, I would say the access possible. Otherwise, it's impossible to access any part of hardware. Okay, so there are a whole bunch of functions, including GUI, device driver, security, networking, then disk management, and memory management, all those things. Oh yeah, I didn't talk about the networking, but that's one of the important part of operating system that interacting with. So the operating system has a lot of functions, doing more of a manager's the function or manager's role. And at the same time, they are very kind helper to us. So there are many examples of operating system software. So this operating system is actually the background of your computing environment. So how you get your operating system installed makes a big difference. If it's a Windows, then there are certain type of the application software doesn't work on Mac OS or vice versa. But right now, there used to be actually that's why I put it in here. If you go to this, click into this website of Wikipedia, then you will see hundreds of operating systems. Many of them you don't even know and what it is all about. But these 4 or 5, they are all we usually care about. One is Windows, that Microsoft, and the Macintosh or Apple computers. The Unix is originally came from Bell Laboratory, and now that it was free, this one was free, so being developed further by universities and young people. So each of those operating system has its own typical this logos. So Windows here, and this is a Mac OS. And the Unix operating system. Hopefully I got a chance to talk about just briefly about the Unix. The Unix is originally it comes from an operating system called the Multics. That's multiple computer system. So there are so many complex ones. Then they said, oh, let's make it simpler. So instead of multi, let's make uni. So uni and the ticks, that the rhyme sounds good. So multics become Unix like that, and that the Unix is the free software, and the C language came from there, and the Sun Microsystem is among others the few. Quite a few of the companies that marketed this software. Then Sun Micro has been then sold to another company, and now you don't see this one company by itself, but their product is still available or they used in the market. Then Linux, this one is really as you see that it is the product or the derivative of Unix. So Linux is the guy named Linus Torvalds, who's the Finnish graduate students who actually, as students, that created the much simpler and but also useful the software of Unix nature. Unix has many advantages over Windows or Mac OS. So they used that this concept and the design to be used in PC. So in a way, Linux is a Unix system working on the PC, the personal computer. So it's very popular. Again, this is a free, what is known as open source software that I'm talking about in the end. So that's open source. And then Android, that there are so many the devices like the tablets or smartphone, they become computer by itself, so they need operating system. So many different operating system has been tested out, but this Android become most successful. So Droid usually means robots. So Android is like the human-like robot, like that is the kind of what the original meaning is. But this one is also very successful. So this one is extensively used for the handheld computer, like the tablet or smartphone. Linux is for the PC more like, but it is not proprietary, so you don't need Windows software or Mac OS to buy. You just have a free. So you can download the Linux program and install to your computer whenever you need. And then the Unix system is more of medium size the software, and the many of so-called servers. Servers is a kind of a software. I think I said briefly, but the that is the client. I mean, it is holding files and operating or the computing power, and let others use it in centrally. That is a server. So that server is has a operating system almost exclusively Unix operating system be used, even if that Windows server exists, but there's nothing like a Mac OS used as a server. So again, you can just click this link and find just browse through what kind of operating system there exists. Then there are a whole bunch of the common applications, systems of application, there's utility and the security, all that relates. So these are all the products in the market. So I already talked about this operating system, and this one is like a zip, and then this is a reader of a PDF format, and some security programs and hard disk drivers. So there are a whole bunch of software there it is. Then this one, of course, you know that this the Microsoft's the IE Internet Explorer. What they do is that going through the websites. So that kind of a software we call what you call the browsers. So browser is application software, definitely. So system software, the another group of system software is that the programming language. So when you want to talk to the machine, you cannot do it by just a regular English. Maybe someday that you can just instruct directly to the machine. Of course, these days there are some robots that will understand your talking and execute your directions. So that translates human speech into the action. But that is a long way to do, and all those sophisticated work is a little harder to do. So the programming languages are the low-level language, as we have seen, that we have talked about. Low level means closer to the machine. So machine can understand and follow. So this is called the machine code. So for example, when you look at, you go to the pizza, the parlor, there are game machine, the game booth, and there are a lot of fancy games. You can see it. You press button, and there's an airplane flying, and the robot is running around. Those kind of game programs are usually written in machine code because it talks directly to the machine and much faster. So somebody can also do the program to run those machines. So that's still programming language. Old days, we had only machine codes, so had to program in machine code, but not anymore. Then there's medium level languages, so things, the very low level, typically the C is one, but assembler is the programming language. So assembly code, that one is specific to a hardware. So there's a CPU has different instruction methods, and there's different way of addressing their location. So it has its own set of instruction that is different from one machine to the other. So this medium level language is assembly language. Then high level is a human understandable form, most common form of the programming languages. So something, like a C programming language, C++, Java, Python, R, and all this, the Pascal and Ada, those kind of programming languages, what somehow look like the English, but it'll translate into the machine. Then very high level languages, sometimes known as fourth generation language, or even so higher level. That is just one very simple code, but it does so many things for you. So database language called SQL, that's a structured query language, or script languages. Those kind of languages are very high, means that it's easy for the human to use this language, and then there's many layers of translation to do to make that one understood by machine. That's the idea. Then the historic programming language, just for the namesake, just you heard about maybe that is that there's a basic programming language, Fortran, COBOL, C, PL1, ALGOL, Ada, Lisp, APL, Snowball, there are a whole bunch of it. So again, there's a list of programming language. In that place you may find a list that a couple of hundred different programming languages ever given on the market and be used by certain the purposes. And depending on the purposes, there are so many different forms. Scala and Ruby, PHP are somehow the more common one. But these days that the Python is something that we recommend because it has very, very simple syntax and very powerful programming language. Then once you have this kind of a programming language, you need a translator. In other words, that if someone says in kind of a human language, so okay, they add 100 with 3. So what is 100 plus 3? And we know 103. Let the machine do it, but machine wouldn't understand our human language. So what they do is that they got to translate it into machine code or at least assembly code so that machine can execute. But to do that, there are two modes. I don't know whether that's needed, but just to giving you the terminology sake. Compiler. Compiler is that there are a whole set of all the program beginning to the end that has a whole total logic. Then translate everything and in one bundle and let it be executed. So almost every program you are buying or you are running are done out of a compiler. It's already compiled. So you once install it, then all you have to do is that just click it so that activates. Then there is a beginning point, and once it's starting a menu part, it is all done by programmer. It's opening the part, and then you start working on it. So you don't have to worry about anything. But there are another group that is interpreter. That is that source program is one that we read one statement at a time. Best way of thinking about this one is that when you are using your calculator, then you type the click, you push number, enter it, and then using that number for next stage, then you do it like that one. So there are cases that needing this kind of a line by line of execution. So Python, for example, has the interpreter mode. So you need instant results of a certain the command and let that be given right away. And then you want to try different number, then you can try different numbers. So interpreter is a little you can get the immediate answers, but the total picture is a little harder to get. But the compiler put whole program in one bundle and runs it, so total picture or magnitude can be found it out. So in a way, think about the compiler is you finish the product and run. That's the typical way. Interpreter is that it is like a calculator that interactively use it one line at a time. Then application software is way big, so large collection of softwares, and it can be general purpose or discipline specific, institution specific. There are this classification that people do it, but there are so many cases. Is the kind of the scope is overlapping. It's a little difficult to say exactly this is right or wrong. But general purpose is that the kind of software to be used at any time for any situation. So best example is word processor. Word processor, like Microsoft Word or the Macintosh's word processors, it is used by anybody. It can be a writer, it can be scientist, it can be merchants, it can be any students. It has no purpose given. It's nothing just for the graphics, not for the designer. It is for anybody who wants to handle the documentation. Then you can use it. Same thing with the presentation. You got a certain thing to make a presentation regardless of your discipline. You can be in engineering, or it can be the economics, management, or politics, history, doesn't matter. Presentation is presentation. So what we see here right now is a PowerPoint. It is used in any situation. The spreadsheet is same thing, publish is same thing, and I should have had is the Zoom, like those online conference thing. Then regardless of the situation, it is usable. So that's the general purpose. On the other hand, there's some discipline specific the software. That is that it's just for the graphics. So you are a graphics designer, you want to draw something, you want to put some animation, yes, then this is being used. Or it's mathematics, then math has a special functions that not everybody uses. So the software is different. Then database, music, movie maker, game, those kind of very discipline specific softwares. Then institution specific is tailor-made for a given organization. So for example, that if this is a dentist office, dental office, then that office has a certain setup for the patients and the type of operation or medical service they are doing. So that one is very specific. So they got to tailor-make for their purposes, including those billing statement pages like that, and also school administration for your records and your the transcripts. Those kind of the softwares are very specifically designed for that purpose. And same thing, NASA, the defense, the army, the defense system has very specific software for certain type of a weapon or certain type of operation. So it is tailor-made. So frequently that kind of a software is called turnkey system. Turnkey means that you don't have to do anything, to worry about anything. Just turn on the key and start using it. It's like a car. You don't have to set up anything in the morning. Just have your key and just turn on, and the car start moving and do its job of taking you where you want to go. So that's the kind of institution-specific software is more like. Again, there's so much spectrum of the softwares, and then you can well, actually there is not even a list of application software because it depends so much. So you should search based on like a graphics software or the security software or design software, accounting software separately. And here's each one try to be identified by certain icons. So honestly, there's some of this I don't know what it is, but it looks like it's all something to do with the icons for your apps. That again, that app, you know, that when you are using your smartphone, that you are downloading and have an apps. That app is actually application. That application software. That's the name comes from. Okay. So how their software look like? Well, I don't know. It says if something is this, and if this is the case, then do this, otherwise do that, and do this, like that. So that's kind of instruction. If this is the case, do it, otherwise do that. Then or this is more of an assembly code. So load R1 into the register 1, put the value of X, and then load X, and then multiply R2 times R1 is X value, R2 is Y value. 2 value is multiplied, and the value is R3. And then R3 being saved to the location A. And multiply that R2, that is Y value, with R4, that is results of R3, R3, and then R4 and R1, they multiply that one into R2. So then add and multiply. That kind of a simple operation instruction. That's what the software look like. So it is a lot of a headache. Then you need the manuals and the instructions how to install it, and when you got a problem, then where to contact. That kind of information can be given in here. So to make a program, that it is composed of a data structure and algorithm. Algorithm is the step-by-step instruction. So to complete a task. So you have this kind of a logic. How do I do that? And then how the sequence of action goes. So this one is called the sequence diagram. So they draw a lot of diagrams and so on, so on. So to write a program takes a lot of design and a lot of planning and a lot of executions of by certain methodology. When you are building a car or airplane, you won't do it by random or by just little pieces, but there's whole plan. So same thing, software must be done. So they used to do the program just the way they like it. Then not anymore. So they decided that okay, let's call that on engineering. The word engineering is coming from the fact that the creating a product or generating a product using scientific and mathematical principles. So when you are building a tree, you are not. When you are building a bridge, then you are not just doing by randomly throwing the stone or steel, but you got to calculate a lot and how much of the base, the foundation will be, and how high they are, what kind of a weight they can bear. There must be a lot of calculation to do. Then same thing when you're designing a car or airplane, then there are a lot of those engineering the consideration. Software doesn't have that many mathematics, but it has a lot of those precision and principles. So around the 80s, people started thinking, okay, let's build our software based on engineering principles. So it is called the software engineering, and that takes some the planning and the requirement engineering. That is that what do you need out of this software, and how to do it, design, coding, and the testing, and the maintenance. A little bit more is explained in the next page. So this is how the software engineering came. You don't have to worry about all the detail, but list that the software is built with a very good care and good testing and good designing. So very expensive and time-consuming effort. So there must be, when it is expensive, but there is a reason why it needs that much of cost. Think about the good programmers. They got all the college, the education, and many years of experience, and they spend hours after hours, day after day, and sometimes almost more than a year or two, and they spend so much time. And the company must pay that person, so they need to charge for the software. So the software is not necessarily free, but people are doing it free because it's very easy to copy. hardware is hard to copy, but the software is easy to copy. So there are a lot of piracies going on. So that's one thing that we are thinking very we need change. But then thought that, oh, this existing software companies are charging too much. So some young people who are programmers decided thinking that, okay, how about we do some kind of initial programming and open up to the public to the whole world. And anybody interested in, just to take a look at this. And will you make an improvement? Let's share it. Let's share our talent and the time together. So that is the idea about open source software. So source code and all the detail about the software is open, and you can download it, you can look at it, and it's free. And then you can make improvement and send it back and add up those the improvement into the features. That will be helpful for each other. So that's the open source initiative up here. So that movement has been very successful, and practically everything, so many part of application software, practically I say everything is found. Every application is found in open source list. So when you get a chance that pay more attention to open source the initiatives and many software like Java programming language, Python programming language, and Linux, I said, is free because it is open source, and the original makers don't take the any financial gain out of that. So that's a very kind of a new trend. New means it's still about 20, 30 years old, but it's a very welcoming trend. Then the software is done, software engineering is done in 3 general phases about defining what it is about and developing. So you're actually writing the program and testing, and then after it is done, then continue on operation after with the quality after it is being delivered. So I just had just the rundown, but this one I just give on the first day of a software engineering class. So maintain wise that the software is created and you bought it, then what they do is that they keep correcting. If there's an error here and there, they will correct it for you, and they send updates. And you can report any error that you found that can be also reported. Then sometimes you want to change your environment from Windows environment to Linux or Android system. Then there's an environment changing. Then software must be somehow adapted. So that's called adaptive maintenance. And the features of that software can be improved as time goes on. So making those kind of improvement is called perfective maintenance. So software is something that is not created once and stay forever, but it's keep evolving, keep improved. So conclusion-wise, the computer software is instruction to hardware for information processing. And software can be into system software that makes the access to the hardware power easy, and the application software that is the more of a productive unit that actually make you use a computer system for your own purposes or for your own benefit. And to build a good software, the software engineering practice is applied, and today free. Many softwares today are free because the open source initiatives. So this all just gives the whole thing, actually, believe it or not, the reason I'm just talking so fast and sometimes the disarray is that this whole thing is worth for 3, 4, 5 different courses. But just to let you know that software is so important, and the thing that you are accessing every day, and the success or failure of a good computer system depends on software, though hardware is very important part of it. But true beauty, innovation, and flexibility comes from software. Okay, that's all. Thanks so much. And this ends the third session.